They increase the engine power and destroy the gearbox, and then they switch back to the original software and comes and say, my gearbox didn't last for more than 9 months, I want a new one. Also, in Switzerland, the police stops and checks the emissions of cars on the street side. And if there's too much emissions, they fine the car company, the manufacturer. Despite that, it's the user has hacked his car and changed the engine control. So they want to design an engine controls. All the computing in the car should not be hackable. But at that time, I was the project manager for the Internet in Cars project for General Motors in Europe. Actually, it was me who designed that. And as I mentioned for some of you, I could sit at my desk in my office and turn off the brakes on our test cars that were out driving. So we realized we have to have really, really good security. And also all the other car companies had the same problems. We had a big meeting here in Europe and shared ideas because it's a common problem. If one internet car somewhere gets hacked, no one can sell internet cars anymore because people will be scared. So it's not competition, it's a common problem. And so I designed a non-hackable system, like a trusted computing system. Everything was encrypted, signed. It was fairly hysterical. We had multiple keys at the car manufacturer. Different people living in different cities had each one key, and all of them had to use the key at the same time to sign new code or stuff like that. Not at the same time, but the code has to be triple signed and stuff like that. So we made a system that was, well, virtually unhackable, unless there is any lags, of course. And the problem for me was that I made it too good. My system was the best, so then they wanted it in the tanks in Europe. But I don't want to build tanks for dictators, so I said no, and that meant I lost my job and I'm not allowed to work as an engineer in Sweden anymore. So that's why I had time to do my peer-to-peer research. That's the short version. So if you want to ask anything about cryptography later on, I probably have some stuff to share. Yeah. Well, anyway, that was a little detour. Can I remove all this stuff? Yeah. Yeah. We talked about stealth yesterday, right? If you want more about that, I can repeat it, but perhaps it's a waste of time. Okay. Oh yeah, that's why also. I'm going forward too fast. Okay, we'll just jump on to the next subject. Also a thing that isn't really peer-to-peer, but has to do with any kind of computer communication. If we have a software, and we get new versions of it, new version number, usually when two nodes connect with each other, we tell the version number. I'm software this and that with version number that. And that means the two nodes can know what the other node will understand and stuff like that. But that doesn't work well if the one node is older and the other one is newer. The new one has to adapt to the old one, but the old one can't adapt to the new one very well. Also, as you guys know from open source, we do get what's the word for that? Forks. So, and forks, then it's just not just version number, then it's product name. And that's, as you've seen, if you've seen the headers from web browsers, it's just ridiculous. It tells what kind of software is. Yeah. It quickly gets ridiculous and hard to interpret. And I actually invented a way to handle that I think is pretty neat. So I thought I should share that because it also saves connection time, connection bandwidth. So what I do is, it looks almost, at first glance it looks like the header you get from a web browser. That is, you get a lot of, it's a comma separate list with names of all your abilities. I can zip, I can compress with that, and I can understand this call, and I can send you this data, and just a long list of well, strings of words telling what I can receive, what I can send, what I can offer or do, all of that. Just like in the header. Have all of you seen the HTTP headers that the browser sent to them? Okay. No, has someone not seen it? Yeah, so you know this list, kind of. I realized I don't need to send all the list, because most nodes on the network have met them before. We have seen software of that version before, 100 times before, but because when we bump around and connect around in the peer-to-peer network, we meet that kind of nodes all the time. So actually sending the whole list again and again and again, that's just stupid. I simply hash that. Hash that down to actually not 20 bits is enough with 20 bytes, I hash it down to 10 bytes. That's enough to almost never get collisions. So when a node tells another node about the third node, I tell them about IP number, port number, the hash of their public key, and the hash of their ability list. I call this an ability list. So this hash is actually, this is instead of the version number. So if my node here is about some other node that has a hash I recognize, it says, oh, I know what that node is. I have stored on my disk, I have a copy of its hash, ability list. So I can just connect to that node, and during connection I tell them I think you have this ability to hash. If he by that time have upgraded his software, will say, no, I now have this list. It will send me its new list. Or if it's a new node I've never seen before, I will say it as to it, I think you have this hash, or that's not, you don't even say, I don't know your ability list, give it to me. So the first time we'll get it, and we'll hash it and store it. This means during connection I don't need to send 1 kilobytes of abilities instead of just this hash. So each time a new kind of node comes to the network, it takes some time, and then everyone will learn about it. And also, if a node has never been connected before, it will be slightly slower the first hour when it learns all the ability lists from all the different versions. But then forks aren't relevant anymore. We're just interested in what can they do and not do. And of course these names must be very clear. You can't, if you change what this one means, then you have to give it a new name. But since we can be very talkative, because we don't need to send it, we can have really long names and even have company names like we can even name things like this, near form dash or whatever you call it. And this is a function and we know what it does. So we can actually have very chatty long names here and stuff like that.
Near form like echo.
Sorry? Yeah. So it's just a little trick to save connection time and handle all the different versions neatly. Well, as you've seen, when we have, for instance, a disk hash table, we have many layers, we take part in many connections, we do have many random walkthroughs, so we have lots of connections going on, so we want to save bandwidth on each connection. So I think that...
When you take a, like you're saying, just take 10 bytes of the hash, yeah. It's safe to just take the first 10 bytes of the hash, isn't it?
Yeah, well, any 10 bytes. Yeah, because all the bytes are... Okay, perhaps I should talk about hashes.
Can we go back to that list of abilities?
Sorry?
Can we go back a little bit to the ability list?
I'll explain a bit later.
What's your thoughts on having normal names on abilities? Shouldn't they be hashes as well? Like if you have 20 different services. I don't know, if Peerconf releases has some service and it changes version, etc. Then you have to change the actual name of the service.
Yes, if you change how it works, you have to give it a new name.
Okay, yeah.
But it could be a version name. You can have a near form could use NF as its prefix. Near form, okay, let's call it stat max. That's a function to calculate maximum. And you can have a version number, so you can call it statmax3 when you upgrade it to a new one. Something like that. It's up to you how you name it. I don't bother about that. So anyone who forks could put any name they use there, but perhaps use a prefix or something to avoid collisions. Of course, if they collide with names, then we're screwed, but they have to cooperate about that. They have to publish their list or something
Yeah.
on the webpage, or they have to corporate level.
This is the thing where, you know, the argument about the EPM like namespaces would actually be necessary to have namespaces if you're publishing peer-to-peer.
Because you've got clashes.
Oh, this.
I didn't understand what you said.
I
I didn't hear it.
was just sort of clarifying what you were saying in terms of stuff we're familiar with.
But this, the humans have to handle to avoid
Yeah.
collisions here.
Yeah, but I think it's better if you just use a hash instead.
Of these
I mean,
ones?
let's say that my node wants to now node and he wants to like download the service on that node. It might collide with any other services that the node has.
Yeah, but you have to give them a long name so you don't get collisions.
Well, we have like there's like 25,000 NPM modules published. People complaining that someone else, like if people work on the same problem, they end up trying to publish the same name, and so we really get a lot of human collisions.
Yeah, so actually I don't know how to handle that part very well. Otherwise, and then having longer prefix. One thing that people have done before in some systems I've seen, it's they usually use it backwards for some reason. Com.
Oh, yeah.
Dot. Year for.
All the Java people are twitching.
Why? Okay, it's okay. It's dot.
You can have a folder for each one as well.
And then
Yeah.
Oh,
That works. Or?
it works. Yeah.
Yeah.
But that just defers to another like centralized authority because that's like the domain name registration system.
Sorry.
That's the domain name registration.
Yeah, that's the
system.
domain name that you or
Like perhaps what you could use is the prefix as like as the hash of your private key, of your public key. I mean.
Yeah, that would be better for them.
Yeah.
So but that's
Not readable,
I
not very
haven't,
readable, but
I haven't thought that far, but
Yeah.
but probably it can be improved like that probably. I'm thinking also one thing I'm thinking perhaps in that instead of having this on every name, I could put like the first name in the command list could be some unique name. That means that gives you kind of a namespace for the rest of the ones, and then you can change namespace for some because you will have functions that aren't yours that others people have initiated. So perhaps something like that, so it becomes more like a tree, but I haven't looked into that, but because my little invention is at least to have a hash of the whole thing. So how we do the rest of it, I haven't decided, because I haven't built my system yet. But yeah, that's a good idea.
Sorry, Rod.
Third?
Back to the last question.
By the way, actually it's just not one ability hash, because we have one ability hash when we connect for the encryption part, the stuff, the connection. Then we might have one for the mother net, one for application net, for each layer, because we have different functions that is not necessary to give the whole thing for starters. Because for instance, the connection part might be fairly standardized.
You're already talking about the mother net.
Yeah. Then you can behave like a standard node there, and you don't need to need to have the full ability list up there. So it might be a few layers of that. But I haven't actually decided on what is the optimum approach since I haven't built my system. So, but that's just some ideas how we can save lots and lots of bytes during connection time. Yeah. Oh, okay. A little about encryption. Well, let's say this isn't routing overlay, instead my structure with the mother net. Applications. Net or subnet, whichever you prefer, and should I write the text larger?
that's what's
So, on the mother net, as I said, it can be fairly standardized because everything that happens there is fairly standardized. It's a limited amount of stuff you do in there. So, when we connect with encrypted connections there, we use, the node can use one key for that, one public key pair for that, and you can use another public key pair for this level. or rather, the application will have a key that all the nodes in that application have a hard-coded key.